So now as we continue to talk about momentum, we're going to explore its application in collisions. Before we do, we got to talk about finding the momentum of a system of objects. So we can find the momentum of one object like we did in the last video, or we can find the momentum of several objects. Okay, so for example, let's say that we have a car. We'll just make a box with a mass of 3 kilograms, and it's going this way with a velocity of 4 meters per second. And then we have another block. Say this one has a mass of 2 kilograms and maybe has a velocity of 5 meters per second, also going this way. Okay? Well, if we want to find the momentum of this system, we're going to use the same process, and we'll plot both of them on here. So we have 3 kilograms and 2 kilograms. The 3 kilogram object had a speed of 4 meters per second. The 2 kilogram object had a speed of 5 meters per second. And we want to find the total momentum. Okay, well, that would be, in this case, be mv plus mv. So 3 and 4 make 12 kilogram meters per second, and 2 and 5 make 10 kilogram meters per second, giving us a total of 22 kilogram meters per second. So this represents the total momentum of our system. So here we have a system made up of 2 railway cars. Okay, what's the total momentum of this system? Well, you should find the momentum of this car is 600. The momentum of this is 800. We add those together to get 1400. So momentum is a vector, which means the direction it's traveling is really important. So in this system, we have 2 objects, and they're actually traveling towards each other, and we're finding the momentum here too. They have to work a little bit differently though. Okay, so this 4 kilogram object has a velocity of 5 meters per second. Meanwhile, this 3 kilogram object has a velocity of 6. But how could I show that it's going the opposite direction? Well, one thing I could do is have it go downward, okay? Because if it's going opposite, we could say that it has a negative velocity, okay? So when we find momentum, 5 and 4 makes 20 kilogram meters per second, while 3 and negative 6 makes negative 18 kilogram meters per second. We add those together and end up with 2 kilogram meters per second as our solution. Okay, so here we have an elephant and a zebra, and the elephant is walking east with a velocity of 3 meters per second. The zebra is walking west with a velocity of 4 meters per second, and I want you to find the total momentum of this system. Okay, so the zebra has a velocity of 4 meters per second, a mass of 200, so we can multiply those to get 800 kilogram meters per second. We'd say maybe they're negative because he's going this way. Meanwhile, the elephant has a momentum of 1,000 kilograms times 3 meters per second velocity, so 3,000 kilogram meters per second. It's going this way, so it'd be positive, and they would subtract to get us 2,200. So this is significant because in a collision, the total momentum has to be conserved. Okay, this is something that comes out of Newton's laws from last semester, that in all collisions, the total momentum must be conserved. Okay, and so when 2 objects collide, some momentum can be transferred from one to the other, but that total momentum of the collision before and after have to be the same. Okay, which is really interesting and kind of cool, and is a way that we can do some pretty interesting predictions and calculations using momentum based off of this knowledge. It's also the reason why, so for example, if you've seen pool balls, it's why one of them would stop when the other one starts rolling. Okay, and this is also so here's like a visual example of that. And if you've seen the Newton's cradle at the front on my desk, that's the same principle going on there too.